Because Europe, I'll get to the point, don't worry. I didn't expect it to be that quick. Europe's in a bit of a problem at the moment. I'm preaching to the converted here because you're all innovative, open-minded people. Did you know the US tech sector contributes 7 trillion to its economy? 7 trillion. China, 2 trillion. Europe, 700 billion. We're over-educating ourselves. We're under-innovating because we're too logical, we're too safe. We look back at the Renaissance and the Industrial Revolution with pride, but we've forgotten how to do it ourselves. We define innovation, it's so incremental, you can hardly notice it. I'm not going to give you the problem of solving it here, but I think this is a thing to think about. Logic doesn't create new value. Logic is yesterday's data. It's based on yesterday. So, and a very deep, powerful thought, hopefully, I'm going to introduce the next speaker, Christian, from Evonik, and they're a new partner for us. And have a great talk, and thank you for being a part of FuturePrint. Over to you.
Thank you so much. Yeah, thank you so much for being able to present here, to embrace together with you the future of inkjettings. Let me give a few words on the company I'm working for. We are not providing AI solutions. We are not providing dryers. We are not providing print machines. We are not even providing inks or coatings. We are a company doing specialty chemistry. So what is specialty chemistry? Basically, it's custom tailored solutions for specific applications where we can really make the difference, where we can be in a market-leading position, and where we can drive really sustainability to bring not only the ink industry, but also the ink industry forward to be more sustainable in the future. Evonik is a very big company, and I don't want to bother you with all the technology platforms. This would be another 4-hour talk. I will just give a very short glimpse in one of the business lines, which is specialty additives and their coating additives, where we are, as I always refer to, the alcohol in the beer. We might be a very, very small percentage in the formulation, typically just 1 to 5%. But this 1 to 5%, same as in beer, really make the difference, make the product. So small amount of additives really lead to big effects. So, for example, less maintenance because you have less frictions, things like that. Save energy, get your product much more protected, or be more durable. Today, I will also just come to a very small part of what we are doing, and this is about printing inks. And here, especially addressing markets that you may be very familiar with textile, packaging, and decorative, where we see that the digital transformation is really taking speed. To gain speed, you not only need the high concepts, but you also need the chemistry really below, allowing you to drive that transformation. And one thing that we heard throughout the days, if it's on 2D barcodes, if this is on high-quality graphics, what is always the challenge is to get the real high print quality. So you need to have a crisp image. You have to get a real good readable barcode. And typically, what is the challenge? That you make your drop really count, to be really visible, to print really sharp. When you do it on a porous substrate, like, let's say, cotton or a paper, what is happening? The ink is absorbed into the network, it spreads. So you get a smeared image, and even worse, you also lose color density, because a lot of the stuff that is important to you at the end of the day, this is the color, is also absorbed into the network. If you are on a non-porous substrate, are you on a good side? Maybe not, because you also have the ink spreading, which also leads to kind of a blurry image, which is not really what you want to have. And when you have a blurry barcode, what is happening at, for example, your retailer's cashier desk? It's not readable. So you annoy the people behind you. Yes, you also do that. But as a converter, well, you might also have to pay some fees because they are not accepting your barcode readability. So what do you need? What you need is to have really tailored primer layers, primers that allow you to get a real sharp, crisp image quality. What you can see here, it's just an inkjet print on a deco paper, uncoated, and it looks, sorry for the bad word, rubbish. So when you have primers on top, you can significantly increase the print quality and therefore the high resolution that you want to have. Just as a side note, how do we really understand what print quality means? And it's not only how the drop looks on the substrate. We have there a noise jet expert from Image Expert, which really allows us to do a lot of things to understand what is really happening. But this, as said, just a side note. When we talk about tailored primers, we talk about primers that have silica or alumina dispersions inside their formulation. So what is this alumina silica thingy we talk about look like? So here you can see a TEM image of the silica. So what you see is you have a very fluffy, fumy structure, a lot of inner surface that you can see inside this. So why is this any good? Well, when you have this kind of chemistry inside your primer formulations, you create a really big inner surface in your primer, so the liquid parts can really absorb into the substrate, and when you play also with ionicity, you can also link, for example, anionic inks on cationic primers, which gives great stability. So how does this look like in real life? And I think this is quite impressive. When you see you have non-fumed oxides into your primer, you have intercolor bleeding, it's kind of on the light side of color strength, whereas when you have really fumed metal oxides in your primers, you almost see no intercolor bleeding, really high color strength. So this is what you are longing for, and this is what you want to have. Now, I maybe showcased that this silica inside really helps to give a really good, not only color strength, but dot sharpness. Are all silica or alumina there alike? Obviously not. Otherwise, it wouldn't be special chemistry that we would be doing, right? So when you look on different substrate, and we just took them prototypically for the different end markets we see these raw materials in. For example, on paper, on cotton, on BOPP, or on PVC, you see a blank most of the time. Looks really ugly. Commercial dedicated primers for these applications, you see, help already a bit to improve from the blank. However, if just silica would be the solution, okay, we take a primer, a commercial one, put in some colloidal silica, everything fine. Obviously, this is not the case. So you really need the fumed silica dispersions to get, and here we took the same ink for all the substrates, to get a really nice quality from quite forgiving substrates like paper to very challenging ones like, for example, cotton, or to very hard to wet substrates like PVC. You see with primers containing our fumed metal oxides, you can really get the nice dot sharpness that you want to have. I said that we also can play with the ionic nature, and just as a very indicative experiment why we think it's a great idea to play with the ionicity, what you can see here is something from the lab. So you have a binder and a binder with a cationic dispersion. When you put in some anionic ink, it immediately flocculates, whereas when you don't have it, it just distributes inside the liquid. Same is also true when you are jetting. So here the reaction is a little bit less nice to film, but what you can see, and this is real images from our jet expert, without a primer, with just the binder without fumed silica, it's a mass print. However, when you have a cationic dispersion into the primer, then you see it's nicely flocculated and you get to a resolution that even on a challenging substrate like cotton, you can get a very nice resolution. So just as an intermediate summary, primers really help to improve the quality, the print quality, also the resistance. We see really the improvement with fumed metal oxides in primer formulations compared to commercial primers without that technology. And something which I did not show you in detail here, but trust me or ask me for more data, you need to be a little bit above the critical pigment volume concentration, or in other words, around 60% of these dispersions to get a real nice, crisp result. And just to give you a glimpse on the products, so don't you worry, I don't want to read out all of this to you. However, when we are talking about end applications for textile, for wallpaper or decorative applications, there are solutions as well as for packaging. And when we talk about packaging, we talk about product safety. And for me, this is always so natural that I almost forget to mention that. But of course, we serve our customers with a lot of regulatory services. So on Coatino, you can get all the regulatory information regarding food contact. You get the data sheets, the eco-label statements, also all the inventory list. So all of this is 24/7 available and just a click away. And of course, with a big regulatory team, there is also then the expert to connect to when you really need to dive more deep into your formulation than you can do with just food contact statements. Of course, we have application technology support, and I'm proud to be part of that. That is available to discuss your formulations with extensive knowledge from around the value chain. If it comes to sustainability, we offer, of course, LCAs for our products so that we not just claim we are green, but we have also figures for that. For materials that are based on biorenewable materials, you can get the C14 analysis. And also, and this would be the last part, we are having now also circular solutions, so solutions that really help to boost the circularity of packaging, which is one part of the challenges we are facing today and tomorrow. And with a short video on the product Tegores 1100, the inking co-binder, intended here for solvent-borne packaging inks. I think I'm still quite good in time. That's perfect.
At Evonik, we continuously strive to make recycling processes more sustainable and efficient. With innovation and responsibility, we are shaping the future of recycling. A major challenge in mechanical recycling today is posed by insufficient de-inking. Ink residues left on printed flexible packaging after de-inking adversely impact recyclate quality. Unfortunately, low-quality recyclate have limited uses. Evonik Coating Additives has therefore developed an innovative co-binder tailored to solvent-borne packaging inks, TegoRes 1100. It allows simple modification of solvent-borne ink formulations without having to change existing recycling processes. TegoRes 1100 sets new standards. It significantly increases the de-inking speed and efficiency of solvent-borne inks on plastic films using only caustic soda at low temperatures. De-inking times are reduced by up to 9 times, and recyclate quality is significantly increased. Thanks to this innovation, high-quality recyclates can be obtained that can be reused in high-quality applications. TegoRes 1100 ensures fast and complete de-inking of plastic packaging waste.
Evonik, leading beyond chemistry.
And with that, I would like to thank you all for your attention, and I believe now it's lunchtime. That doesn't mean that you can't connect with me, so if you have any questions, I'm more than happy to answer to you and to network. Many
Fantastic,
thanks.
great talk. Thank you very much. Please do introduce yourself to Christian. And thanks to all the speakers this morning for a fantastic morning.